Good. Welcome back. My name is Jan Hichu. I am presenting a series of short videos on the use of IESve as a building performance assessment program. And in the previous video, we discussed the use of macro flow, the way of defining the window types for each window within the model, and ultimately how that would then affect the performance of the building. So once you've defined all of the windows, you'll see in this case we've defined two types of windows, a top-hung window and then a non-opening window. And there is a little tool on the side called input visualization, um, which is actually quite I think, effective way of checking the model afterwards. Now, you might know what you've defined it for. I know that the one is openable and the one is non-openable, so I can simply use the openable area, but there's, as you can see, many other. You can use opening category, for instance, if you wanted to. And when I then click on this, I can then assess or visualize the implication of the models that I've built. So whether I've actually defined the windows correctly. So in this case, you can see at the top, red is a 30% opening, and you can see that this is both the front and the back windows, and then down at blue is 0% openable windows, and that's the windows on the eastern side of the building. Now, obviously, there's only two types of windows in this model, so it's quite simple to see. But if your model becomes more complex, then this is quite a nice way to go and check it afterwards. So you can simply use the data input visualization. We've used a similar method in defining construction types and building types and so forth. Okay, so once you know that the model works, you can then go to Apache and you can run the simulation. It follows the same process as we've done in the past. You will define the file in the end. It's good to change that because it saves it under the same file, so you can easily start comparing the output. Remember that the weather file needs to be correct. If it's incorrect, you need to go and change it with aplocate. And the one thing you'll find is before you start, there'll be the macro flow will not be ticked. So you'll have to go and click on that, and that will then include that in the analysis. So now you will include the window openings and that performance in it. You have to check beforehand whether your model actually is including natural ventilation and so forth. So under your building template manager, you'll have to go back and make sure that the model is actually naturally ventilated, or in this case it's naturally ventilated. Note that we changed it to natural ventilation. There was some previous models where we looked at air conditioning, but the flow is still 7.5 liters per second. Per person per second. So I haven't adjusted that, and it has considered that into the model. So you don't need to change the flow rates per se, but you have to, and you can obviously also include these models with an air conditioning system, and you can see what happens then. Again, test it and see whether it works, and if there's any anomalies, then you need to just check your model, or you might be learning something from it. So I'm not going to run the simulation now. We've done it already, and you know how to do it. But if you go to IES, to the Vista Pro tool, you should be able to view the impact of it. Now, a very easy way to check it is, in the past, I have discussed this with you, the various aspects that you can view. And I think a very simple way to view it is the temperatures in the rooms. And you simply choose room, choose the floor that we'll be assessing. You click on air temperature. You can lock it if need be. And up here at the top, you'll see the three results that I've analyzed so far. The first one, and you'll see, is based on windows that don't necessarily open, that they follow a basic ventilation flow, but there's not specific opening sizes defined for it. and a schedule for that. So on a typical summer's day, I think it's easiest to view it on one day. You'll see there's a basic flow. The the it's started quite cool and slowly gains heat up to 3, 4 o'clock in the afternoon, and then slowly we start losing energy again, as people start leaving it as well. If we look at the air conditioning option, we can see the air conditioned option actually starts at 26. Now you'll note here that we're never lower than 25 in summer. So the argument here is that it starts ramping up the air conditioning before we start, before everybody arrives, but the air conditioning really only switches on at 8 o'clock. Then it runs at 25 degrees Celsius, so it's nice and comfortable. And then there's lunchtime because the air conditioning was linked to the occupancy schedule, so it basically switches off over lunch and then it switches back on, and we can see that's the, the graph that we get. If we start opening windows, we see a little bit of a different flow. It's in the morning. I mean, the temperature is quite warm. It drops down. It's summer, so it's above 25 degrees. But at 8 o'clock or 9 o'clock, someone starts opening windows, and we see a dramatic drop in temperature. And then slowly we see the temperature gaining again. So clearly the air conditioner, the windows are working, but it's not necessarily working that well, because by 5 o'clock it's still 25.5, and then the windows are closed and we see a temperature gain. Now you'll see it most clearly when we start comparing the two models. Now remember, this is the two naturally ventilated models. The first one simply has an S-curve that just basically shows that as people enter the building, there's heat being gained inside the building. So clearly there's a difference when you start opening the windows, and that is within the model. But we can see that if you compare the two to air conditioning, then there is a slight drop below 25, and then we don't necessarily get there. And like we've discussed in the past, there's multiple ways of viewing this. You can also ask yourself what happens in winter, and you'll see here in winter there isn't necessarily a window being opened. We never really reach beyond 25 degrees, and you should, for that matter, be a very slight difference really, um, between opening and non-opening windows in the end. It shouldn't be there shouldn't be a dramatic difference because the windows are closed. So yeah, you can view that. So this is a way for you to start playing with the types of window openings and what the implications would be. I think you will realize that there's obviously limitations to only using naturally ventilated buildings if you have a high occupancy density. If it's for houses, we often know it works quite well. But there is ways of now looking at ways of ameliorating the indoor temperature through air conditioning systems or night cooling and so forth. All that you can start modeling using the same method. My advice though is always start with the basic model so you know what typically happens, and then start changing so you make that comparison in the end. Okay, so this concludes macro flow, how we define the windows, and ultimately how we assess it in Apache. If you have any questions regarding the use of Vista Pro or the simulation itself, the thermal calculations, please do go back to those videos that I've shared on that. We do discuss it in detail there. Good. Thank you. See you in the next video.